It says recording will start soon. Okay, it looks like we are recording. Okay, so now let me go to the Google Classroom. So present now, and I'm just going to present that Chrome tab because I want to show you guys what is in on every classroom, 4th and 5th period, and this is 3rd period right here. Okay, so today I'm going to go over the actual test on Google Slides with you guys, all right? But then right underneath this, I have a link to our original Unit 1 review, all right? And so that's another opportunity for you guys to get some more help. This is the review you did before you took the original test. And then to the right here, there will be the actual Module 1 exam in a Word document. And you guys, if you have access to a printer, I would print that out and take some notes on it as I'm going through the test. All right. If you don't have access to a printer, you might, open it up later, or, I guess it'd be hard to open it up right now because you're looking at me on the Chrome, but you have access to it there and you can kind of take a look. And again, if you don't have a printer today, just take some notes on your own paper. Okay. So I'm coming back to you guys. And let's see how many people I have here. Stop presenting. All right, man. We got 12 people, including myself. That's not bad at all. All right. So, and everybody that are from 4th period and 5th period, the link worked just fine for you guys, and everybody's in good shape, I assume. Okay. So let's get going then. All right. So what's going to be the easiest way to do this? I think I'm going to go ahead and go my entire screen. Okay, so Jade, you help me out when I go my entire screen. Sometimes I forget that I'm on an entire screen. And if I go to something like Skyward or something like that, hey, let me know that you can see it.
All right.
I shouldn't be showing off Skyward. I count on you, Jade.
You can.
All right, so here we go. Present now, entire screen. We'll hide that. And here it is right here. And I'm just going to go to the 3rd period, and I'm going to go to classwork, and I'm going to open up the original Module 1 exam. Okay, so it's right here, Module 1 exam, and you guys all have a copy, but I'm going to open up my copy of it. And you guys make sure when I'm done talking about this, you guys remind me to delete everything I wrote all over this test. So here it is. Okay, now help me out, you guys. Can everybody see the Module 1 exam on your screen and still hear my voice right now?
Yes.
All right, awesome. Okay, now I'm not going to do this like our typical live lesson where I ask you guys to fill in blanks. I'm just going to go through this process very slowly. It should take us about a half hour. But if you do have a question, it's really important that you unmute your audio and you let me know you need some more help. All right. And don't be shy about that, because if you have a question, I'll guarantee there are other people in the room that have the same question. So you're really helping people out when you ask questions. Okay. So this was the first problem on the exam. And if I remember right, I think every one of these boxes worth 1 point, and then circling the correct thing over here on the right was also 1 point. So there's a lot of points on this very first slide. So let's make sure we all understand it. So number 1, determine if each sequence is arithmetic, geometric, or neither, then find the missing terms. So I'm going to look at A right here, and I'm going to go -37, and then we go -31, and then -25, and then -19. Now, can you guys all clearly see that we're subtracting 6 every time? So what you do is just keep subtracting 6. So -19 minus 6 would be what? -13. And so I click that box and I go -13. And then subtract 6 from that, and you're at what? -7. And you guys, don't let me make an arithmetic mistake here. I'm trying to give you guys a good example. And then -7 minus 6 would be -1. I should be, what am I doing? I'm saying, I'm subtracting. I'm actually adding 6 every time. So -19 plus 6 is -13, and -13 plus 6 is -7, and then -7 plus 6 is -1. Does that seem pretty easy to you guys there? Does anybody have a question right now? Okay.
No.
Yeah. So you guys, since we're adding here, we have a common difference. And circle, arithmetic, geometric, or neither. All right. So if we have a common difference, we have to be arithmetic. So you just grab this little ellipse right here and put it over arithmetic right there. And there's our first problem, part A. Okay. How you guys doing there? Now I'm gonna, okay, give me feedback at the end of each problem, okay? I'm not gonna ask you to fill in blanks again, but I need to know everybody's okay when I'm done with the problem. Okay, now let's look at the next one. The sequence goes 1, -2, +4, and -8. So it looks to me like we're multiplying by -2 every time. So that's a common ratio. So if I go -8 times -2, I'm gonna get a 16. And then if I multiply that by -2, I'm going to get -32. And if I multiply that by -2, I'm going to get a positive 64. So that's the sequence as far as I needed to fill it out. Okay. And I hope everybody's okay right there. Let me know if you need anything. And because we were multiplying by -2 here, that's a common ratio. So that's going to make that sequence geometric. So I'm going to circle geometric right there. Okay, everybody okay with part B?
Yeah.
Yes.
Okay,
Yes.
awesome. Okay, so let's go to part C then. Well, -3 goes to 2, 2 goes to 7, 7 goes to 12. It looks to me like we're adding 5 every time. So let's continue the pattern right there. 12 plus 5 is 17. Plus 5 is 22. Plus 5 is 27. And that's a common difference of 5. So that means the sequence is arithmetic. So just go over here and grab the ellipse right there and slide it on arithmetic. Hey, this is pretty cool. Okay, what do you guys think about C? Everybody good there?
Yes.
Yeah.
Okay, all right. And again, if you have questions, don't be shy. Come on back, we'll go through it. Okay, so now this one, 0 to 1, 1 to 4, and 4 to 9. Okay, now I'm not adding the same thing every time, and I'm not multiplying by the same thing either time. So I know right now that this sequence is neither arithmetic or geometric. Okay, so there's a neither right there. I'm going to go there right now. All right, but I can see a pattern, and I hope you can too. Now, to go from 0 to 1, we added 1. From 1 to 4, we added 3. And from 4 to 9, we added 5. So I added 1, then 3, then 5. So it looks to me like we're adding consecutive odd numbers. So I'm going to add a 7 to the 9 to get a 16. And then I'm going to add a 9 to that 16 to get a 25. And then I'm going to add an 11 to that 25 to get a 36. And that's the pattern. Now, you guys, this chapter, you know, our focus was arithmetic and geometric. So I promise you, I will not give you a neither on the retake. It's either going to be arithmetic or geometric. But again, you guys, if you can see a pattern, even if you don't have a common difference or a common ratio, all right, this curriculum expects you to be able to continue that pattern just like that. Okay, but again, on the retake, I'm keeping it to the core concepts of that module. All right, because I mastered. Okay, so that's slide number 1 right there. Okay, let me know what your questions are right now. Because you guys know, oh man, this isn't like my PowerPoint presentation where I can break out a pen and scribble it all over it. Oh well. Okay, so is everybody okay with the first slide? We ready to move on?
Yes.
Okay,
Yes.
Here we go then. Slide number 2. So the sequence below is arithmetic. What will the next 2 numbers in the sequence be? All right, so if this sequence, which they only gave me 2 terms, is arithmetic, that tells me I have a common difference. So 3 goes to 9. That means we're adding. And what did we add to that 3 to get 9? We added 6. So I'm going to add 6 again. 9 plus 6 would be 15. And then 15 plus 6 more would be 21. So that tells me the next 2 terms here would have to be a 15 and a 21. So now I just grab my ellipse right here, and I'm looking for A, B, C, or D that has a 15 or a 21. That's close, but that's 15 and 45. And there it is right there, 15, 21. So I'm just going to circle like that, D. And now double check. Does this make sense? 3, 9, 15, 21. Yes, we added 6 every time. So what questions do you guys have on number 2? Okay, you guys ready to go to number 3 then?
Yes.
All right, right on, right on. So number 3, the sequence below is geometric. What will the next 2 numbers in the sequence be? So that means we're multiplying by something. So they gave me the first 2 terms again, 3 and 9. Note the same terms as above, but if it's geometric, that means we have to have a common ratio. What are we multiplying by? And you guys should be able to tell me that 3 times 3 is 9. So I have a common ratio of 9. So that means I've got to multiply by 3 again. So 9 times 3 is 27. And then multiply that by 3, and I would get 81. So I'm grabbing my ellipse right here, and I'm looking for a 2781. Not there, and there it is right there. So the answer to number 3 is B. Okay, so any questions on number 3? Seems pretty simple, you guys?
No.
All right, all right. And you guys now remember,
Yeah.
all right, you take this test today and you get it to me by 2 o'clock, all right, I'm going to correct it and I'm going to replace your test score. So it is like that first test never existed, okay? And Jade, I expect you to improve, but you had a real high score the first time. So if your score drops somehow, which I don't see that happening, but again, if your score drops, you guys, I'll just leave the original score in there. But I'm anticipating everybody's scores goes up here. All right. Number 4. If the sequence below is arithmetic, determine the missing numbers and the common difference. Okay. So now this, they're throwing a little bit of a curveball because they don't give you the second term. They gave you the third term, the first and the third. But so what you think is, okay, I have to add a number to 3 to get a number right here, and then add the same number to this number and end up with 27. All right? So the easiest way to think about that is, well, what could my common difference be? Well, it took me 2 steps to get to 27, right? So think about this then. How far is it from 3 to 27? That would be 24 units. So does it look like then in 1 step I would be adding 12? So let's try this. So just go over here to the common difference and let's put a 12 right there. And now let's just see if that works. All right. And again, does everybody see how I am conjecturing that my common difference is going to be 12? Because I'm taking 2 steps to go from 3 to 27. And the distance from 3 to 27 would be what? 24 units. Half of that 12. Half of that is 12. So here's my check now. 3 plus 12 is 15. And if I add 12 to 15, I get 27. So it works. So I already know my common difference is correct. All right. And I know this is correct. And now I just have to add 12 2 more times. So 27 plus 12 is 39. Plus 12 would be 4951. And that's number 4. Does anybody have a question on number 4 right now? Nope.
Nope.
Nope. Okay. We ready to go to number 5? I need to hear from everybody here. Right
Yeah.
on.
Yeah.
There we
Yes.
go. Here we go. We're in there. Okay, good. Thank you, guys. Okay, now number 5. If the sequence below is geometric, determine the missing numbers and the common ratio. So now, again, they don't give us the second term, only the first and the third. And notice it's the same as above. But now this one has to have a common ratio. All right. So now, here's what I want you to think about here. In 2 steps, I went from 3 to 27. All right. So I am thinking right now, I have a common ratio of, guess what? I'm thinking 3. And here's how I got the 3. Well, in 2 steps, I went from 3 to 27. So I'm thinking 3 times what number would give me that 27? And that's a 9, right? But then that means I take the square root of that 9, which is 3. And here's how I check to see if it worked. Well, 3 times 3 is 9. 9 times 3 is 27. So I know this is correct, and I know my 9 is correct right there. Now, let's go 27 times that 3, and I'm going to get 81. And now, you guys, if it's tough right now on the multiplication, you just break out your calculator and do this very carefully. So I'm going to get out my calculator just to set the example for you. And I'm even going to check that 27 times 3. So, because I want 100% on my test. So I'm going to go calculator, clear, and I'm going to go 27. Oh, I hit a 3, excuse me. 27 times 3. And that is 81. I'm right there. And then I just go times 3 one more time. And my calculator says the last answer times 3. And that is 243. So I click this box right here. And I put the big old 243 right there. And there's number 5. And that's our second slide right there too. So does anybody have anything you want me to go back on the second slide? Number 2, 3, 4, or 5?
Nope.
No? We all good out there?
Yes.
Yes, sir.
Right
Yeah.
on, right on. Okay. Hope you guys are feeling confident. All right. Now, and by the way, when you guys are taking your test, don't be afraid. All right. I have no writing tools right here on this, but I could do a text box if I wanted to write to show work, or you could just have a piece of scratch paper out. Like this, it might help you on number 6. And number 6 is worth 12 points on this test. The reason is this is just way too important. All right. They give you when f of x equals negative 6x plus 4. So they gave you an explicit formula. And by the way, that's linear. And your slope would be the negative 6 and your y-intercept would be the 4. All right. But when they give you an explicit formula, you should be able to find f of any number with direct substitution. So let's look at this first one right here. What is f of 1? And we've been talking the language of function notation all year. So this simply means I'm going to go back here, and this x right here now is a 1. So all I do is my order of operations. I go, okay, negative 6 times 1 is negative 6. And then I have to add 4 to that. So negative 6 plus 4, I'm going to go over here and I'm going to go, hey, I have negative 2. Now f of 2. Well, now the x is a 2. So negative 6 times 2 would be negative 12 plus 4. And I get a negative 8. And then f of 3. All right, well, the x is a 3 now. So I can go negative 6 times 3 is negative 18, plus 4 would be a negative 14. And by the way, you guys, if you're struggling doing the arithmetic in your head at all, you could put this in your calculator exactly the way you see it. So let me do a text box right here to show you. If I wanted to punch each of these out on my calculator, all right, I would just do this. Equals. And then on my calculator, I would hit my negative 6. And then where the x is, I'm going to do a parenthesis. Parenthesis, that's not a parenthesis. And then what's my input for, let's do the 3 right here. The 3 is my x. So I go 3. and then I close that parenthesis, and then all I have to do is add 4. Now, if I put that on my scientific calculator just like that, -6 times 3 plus 4, and notice the x has just been replaced with that 3 right there. All right. Then I hit enter, and guess what my calculator is going to do? It's going to give me that -14. If you have a moment, try that right now. So that's 12 points. You want to get all of those correct. It's only one problem worth 12 points, but it's one of the more important problems on this test. That is why it's worth so much. Okay. What do you guys think? Okay, no questions out there. Are you guys ready to go on to the next slide then?
Yes. Yeah.
All right, everybody there, awesome. Okay, oh, I love this next slide. It's just 2 multiple choice questions.
Mr. Gibbons, can you go back to the second slide for a second?
Yeah, I sure can. This one right here?
Yeah, just...
Okay, you got it. Tell me what you need.
I don't need anything. I was just trying to continue my notes on it. And you...
No problem. I appreciate you taking the good notes. You let me know when you're ready to go back to that number 4 then.
You can go number 4.
Okay, thank you. All right, now, multiple choice. Now, you guys have become experts at recursive formulas, and I am really proud of that. All right, look at this recursive formula. F of 1 is 2. That tells me in my table, my first n will be a 1, and then my f of n will be a 2. So if I look at the 4 tables right here, I'm looking for n is 1, f of n is 2. A is a possibility. B is not, because that's a 1, 1. C is a possibility, and D is not. So just by knowing your initial term, you've already cut down to it's either A or C. Now, look at the pattern of change in the recursion equation. We're multiplying by 2. So f of n is f of n minus 1 times 2. So I just look at my f of n's in table A and table C and determine where my pattern of change is multiplication. So let's see this. 2 times 2 would give me a 4, and 4 times 2 would give me an 8. So I already know that the answer to number 7 is A. See, over here on C, I'm adding 2 every time. C is telling me I have a common difference of 2, while A is telling me I have a common ratio of 2, which means I'm multiplying, and that's what that times 2 is right there. Does anybody have a question on number 7?
Nope.
Nope. Everybody good there? All right, right on. So moving right along then. Now, number 8 is explicit. And this is an exponential function. And I know exponential functions are new to you guys, but we've been looking at them almost every day. And I hope this is really easy. You just got to know the parts right here. Okay? So now, when I just have a number to the x power in an exponential, that tells me that my first x in my table has to be a 0. Now, if that were x minus 1 up there, my first x could be a 1, but it's just an x. So my first x in the table has to be a 0. So I already know the answer is either B or D. Now, I think about this. Okay, that 3 is the A in the general formula, and that's my initial output. So I'm looking for the first point in my table to simply be x is 0 and f of x is 3. You guys, look at B. X is 0, f of x is 3. It has to be right there. And if you are not 100% sure, just check the next one. Do you see the next x is a 1? Well, if I go 2 to the first power, I get a 2, and then times 3, and that's a 6. And then I look here, 1, 6. I know it has to be correct. So that is slide number 4 right there, problem 7 and 8. Does anybody out there have a question? Okay, are we ready to keep on moving, you guys?
Yeah.
Okay. Now, oh, I see it already. This is my favorite problem. Although it was tough to squeeze this little box up here. You see how I had to kind of cover the line? I was kind of distraught about that, but I got over it in a little bit. All right. Now, match each item on the left. So on the left, I either have explicit formulas or recursive formulas with a different representation from the same sequence on the right. So on the right, it looks like I either have a table, a sequence, or a graph. Very cool. Okay. So, and I can't write on these, so I can't cross them out right now. Man, I wish I could. Hey, maybe I can just add something here. Is there a pen right here? There must be a pen on this. I forget, you guys. Yeah, I can do a squiggly, I think. Okay, so I'm going to do that. Okay, so I look at number 9 then. Okay, this is exactly what I was just talking about on the last problem with the exponential right there. Okay, now on this problem, I have an x minus 1 power right there. Okay, so I'm looking for my first input is 0, and that could actually occur on a sequence or in a table. All right. In fact, on the makeup exam, I believe I put a little note that we're going to start our sequences with the first term being the 0 term. All right. But anyway, so that doesn't tell me a lot with when I look at the sequences, but look at the tables right here. Okay. If I'm going to use a table or a graph, my first input has to be a 1. So right now, I see that table's a possibility, and I see the graph's a possibility. And really, it could be any of the sequences too, because I could say that that's the first term instead of the 0 term. So that didn't tell me that much. But now, this 3 has to be my first output. So I'm looking for an input of 1 and an output of 3. 0, 5 is out. 5, that's out. 6, that's out. Okay, so do you see that in D, the first term of the sequence is a 3? That's my A. That's a possibility right there. All right, now also in E, this output right there, well, that's 3 units up. So when X is 1, I'm going up 1, 2, 3. So right now, I know that 9 is either D or E. My question is, which one is it? So my base is 1/2. That's what we're multiplying by every time, you guys. So check this out. 3 times 1/2, that would be 3 halves. 3 halves times 1/2 would be 3/4. 3/4 times 1/2 would be 3/8, and 3/8 times 1/2 would be 3/16. So I know the answer to 9. Already I know it. It has to be that sequence D down there. So there's a D. Some of it's a D right there. And then I'm going to get out my pen so I don't get confused. And I'm going to scribble. I'm going to cross out that D right there. I use that. You're done. Okay. Now, I go to 10. Now, the recursive is way easier because f of 1 is 6. So now I'm looking for an x is 1 and an f of x is 6. I see that already right there in the table. Now, times 2, that means I'm multiplying my f of x's by 2. And look at this. 6 times 2 is 12. 12 times 2 is 24. 24 times 2 is 48. We got it. The answer to 10 would have to be a C. And now let's get the scribble out again. Boom. I'm done with you. Done. All right. And the cool part about this matching problem is the farther you get, the easier it gets. So, and then they gave you another recursive. This is the easiest. Now I'm looking for my first term is 3. F of 1 is 3. Well, this table doesn't work. That's an f of 0 is 5. Well, then I got a 1, 3 next. So possibly, but I doubt it. All right. So where am I then? Right here. Oh, look at this. The first term, no, that's a 5 again. Oh, look at the graph. When x is 1, f of 1 is 3. I think it's the graph. So then I check. Am I adding 2 every time? Well, f of 2 goes up to 5, f of 3 goes up to 7, and f of 4 goes up to 9. That's it, you guys. So the answer to 11 is a big old E right there, and we cross that one out. So scribble, you're done. And now I just have 2 more models to work with over there. All right, so this is explicit. 2 times the quantity x minus 1 plus 5. Now that tells me that my first x is going to be a 1 and that my first f of 1 is going to be a 5. So I'm looking for 1, 5. All right. Well, the table is 0, 5. This sequence, they're using that as a first term, 1, 5. So I say it's got to be a B. So I'll put a B right there. And I break out my scribble. Where are you at, scribble? There you are. And I'm going to cross that out now. Gone. Now, I could right now go A right now because that's all that's left. But I want to double check it. Is f of 0 5? Well, look at that. X is 0. F of 0 is 5. True. And then I look at the minus 2. That's my pattern of change. So I look at my f of x's. Am I subtracting 2 every time? Why, yes, I am. So the answer there is A. So on slide 5, which is my favorite slide, I'm going D, C, E, B, A. That's a great slide. Now, I'm going to come back to this, but I'm getting a couple bings, so I want to check email, make sure somebody's not struggling to get in here. Janelle? No? Okay. And Susan. Okay, we're fine. All right. So then, hey, let's get back. Where was I at? There it is right there. Okay. Now, does anybody have a question on that slide? That's a cool one right there. And I'll go back and talk about anything.
Nope.
Don't be shy now. All right. Now, I'm not having one pacer, so I'm going to ask you all. Are you guys all ready to go to the next slide?
Yeah.
Yeah.
Yeah? I'm looking for a few more yeahs out there now. All right. So now we get to the cool stuff right here. All right. Number 14's kind of lame, actually, but it's a very simple problem. And then we get into the models where we're doing recursive explicit and stuff like that. All right. Now, number 14. List the functions from 9 through 13 that are in recursive form. So that means I just go look at the previous slide again, and I'm looking at the functions over here on the left and which ones are in recursive form. Well, 9 is explicit, 10 is recursive, 11 is recursive, and 13 is recursive. So I'm just going to go over here, and I'm going to go, bam. What was that again? 10, 11, and 13. Not 143, 13. That's all they're asking you to do there. Does that make sense, you guys?
Yeah.
Yeah. No questions? Okay. Now let's find the explicit. List the functions from 9 through 13 that are in explicit form. Okay. Well, 9 is explicit. F of x equals. And 12 is explicit. F of x equals. That's it. So a recursive has 2 parts, and explicit only has 1 part, f of x in terms of x. So that was 9 and 12. So now I go over here and I just go 9, 12. 9, comma, not period, comma, 12. And I think those 2 boxes were worth 1 point for each number. So that's an easy 5 points right there. Okay, what do you guys think about number 14? Question? Question? No?
No.
All right. Well, heck, let's get this finished and get you guys going on your makeup. All right. Use the graph at the right to 1. Write the recursive function for the sequence. I love it. All right, you guys now look. You look at this first point in the graph. The x is 0 and f of 0 is 8. So I'm just going to go over here and I'm going to go, hey, my x is 0, and f of 0 is 8. That's my initial condition in function notation. The first point in the graph, x is 0, and f of 0 is 8. And now I just got to think about my pattern of change. So what is happening to my outputs, f of x? Well, when x is 1, f of 1 is 6. And then I'm dropping down to 4. And then I'm dropping down to 2. And then I'm dropping down to 0. So it looks to me like we are a pattern of change. We are subtracting 2 every time. Minus 2. I have a common difference of negative 2 right there. Does that make sense, you guys?
Yes.
Okay. Write the explicit function for the sequence. Well, you guys, that looks to me like linear decay right there. I know it has to be linear because my pattern of change is we're actually adding negative 2 every time. So, and remember, right here, f of x equals, all right? And did I put that in there right? Let's see. Yeah, I'm going to go right here. Okay, f of x equals. Now, we're going to go mx plus b. Put that in your notes, man. If it's linear and your first x is a 0, you're thinking mx plus b. Use that last year. All right? So my pattern of change is negative 2. That's the slope of this line right here. I'm dropping 2 and I'm running 1. Remember, a common difference is always your slope. So I'm going to go negative 2 and then x, because I have my first x is 0 right there. And then what's my y-intercept? That 8 right there. Plus 8. There's my explicit formula right there. So there's the recursive for 15, and 15b is the explicit. Okay, are you guys good right there?
Yeah.
Okay, now f of 100. Well, now f of x above is f of 100. So that means this x right here is 100. Now let me go a text box here real quick, because let's say you're not comfortable doing all this arithmetic in your head. Get your calculator out and let's type out the expression negative 2x plus 8. So go equals negative 2. And now where your x is, put a parenthesis, and they're asking for f of 100. So go times 100. And then what? Add 8 to that. Plus 8. Now you can put that in your calculator exactly like that. Negative 2 and then a 100 in parentheses plus 8. And what does this mean? Your calculator then will go negative 2 times 100 is negative 200. And if I add that 8 to that, I'm going to be at negative 192. There you have it. Isn't that cool? So make sure you can punch that kind of stuff out on a calculator too, you guys. It's too important and too easy not to. Don't make an arithmetic mistake. All right. Questions there? I'm waiting. I'm ready. I could even try
Can
to
you stay on that slide a little longer?
I'll stay on this slide a little longer. You let us know when you are ready, okay? Thank you. Appreciate that. I got somebody out there taking some great notes. I wish I could see you guys' faces when I'm doing this, but I can't. I'm sorry. I do always recognize Jade's voice for some reason. I think because she talks to me so much. Jade, I'm not saying you talk too much.
Okay, I get told that by like every teacher. It's okay.
I'm betting you talk a lot on all this remote learning. I'm just gonna bet on
questions. Okay.
And you know what? That's how you learn, and that's why you do so good in school, Jade. So I'm gonna represent all your teachers and just say, Jade, thank you.
Oh, thank you. Thank you.
Okay, so again, I couldn't see who asked for more time, but make sure you let us know when you are ready. And you all just kind of relax a second. You know, do the deep breathing. Feel good. Think about anything else on this test right now. Make sure you guys are ready. Because I'll guarantee you too, not all teachers are going over your first test and giving you the opportunity for a retake this week like your math teacher is. All right. But I do this because I care about you guys.
Okay, I'm ready.
All right. All right. Then I'll quit talking about me and get going here. Next slide. Now, you guys, everybody, I think everybody that took this test, I did have a few people that haven't tested yet, got this slide right. And I was thrilled. All right. Tells me you're an expert on looking at a diagram and creating a table and then a recursive formula. And that's a biggie in this unit right here. So let's read it. Use the pattern of figure 1, figure 2, and figure 3 to create a table for this pattern. Well, guess what? Just by saying figure 1, figure 2, figure 3, they already told me my x's would be a 1, a 2, and a 3. I don't like the way those came out in my boxes, but I can read them. And I see that right here. Figure 1, so that's the first term. Figure 2, that's the second term. Figure 3, that's the third term. And now I'm just going to count the number of cylinders. That's going to be my f of x. So in figure 1, I have 1 cylinder. In figure 2, I see 2 cylinders. And in figure 3, I see 1, 2, 3, 4 cylinders. Oh, I was thinking it would be 3, but it's actually 4. Very cool. There's my table. Is there a question on the table there?
Nope.
Nope. Well, good. Okay. Now, the recursive formula that you guys are experts in. This is why we do this every day. And I can't help it. I know I wasn't going to have you guys fill in blanks, but you know, this is my favorite part right here. Door number 1, door number 2, and door number 3. I'm not going to have you fill in this one like I usually do in the class. All right. F of what? What is my first X in the table?
1.
1. And what does F of 1 equal according to our table?
1.
1. You see that right here. Figure 1 is 1 cylinder. So F of 1 equals 1. And then f of x equals f of x minus 1. And right here, you put your pattern of change. Okay? So 1 goes to 2 and 2 goes to 4. It looks to me like we're multiplying. We have a common ratio. So I'm going to use the little star to mean multiplication. And what am I multiplying by? 2 times 2. And there you have it. What do you guys think of slide 7?
We're good. I think.
Everybody good out there? I need to know. Is everybody ready to roll? All right. Great, great, great. All right. Last slide. This is it. I hope you guys had as much fun as I had. Oh, number 17. I was so impressed with you guys when I looked at the test. You guys did a really good job here. All right. So a student has $15 in their bank account. So as soon as I see that, I'm thinking in a recursive formula, f of 0 is what? Is 15. Now those didn't come in perfect there, but I can read them. F of 0 is 15. Okay. Now let's keep reading. Every week, $25 is added to their bank account. So that means f of x equals f of x minus 1. And then what's my pattern of change? Well, I'm adding 25. So I'm just going to go plus 25. There's that one right there. So f of 0 is 15. And you guys don't get caught up in moving things around and making them perfect. You know, I will here so you can see it. But, you know, I can see it on your test if you fill in the blanks like that. I just moved that thing. I don't want to move that. See, if you start fiddling with this, you know, get yourself in kind of a situation there. So the recursive formula, the initial condition, f of 0 is 15, and then the recursion equation is f of x equals f of x minus 1 plus 25. What do you guys think of the recursive formula? Pretty easy?
Yeah.
Yeah, yeah. No questions? Come on.
Nope.
Not a 1. Now, a lot of you put f of 1 is 25 right there. And, you know, sometimes 0 or 1, either will be appropriate, but that's not often. And I really think the 0 is much more appropriate than the 1. But if you put an f of 1 there and you did everything else right, I did give you most of the credit. So 17b, write the explicit function for this situation. Okay. Well, you guys, as soon as you see plus 25, your pattern of change is adding. All right. So you know you are linear. And your first x is a 0, f of 0. So that means you can just do mx plus b. So what's your m? Oh, I'm in the wrong box. That's the problem. I see what's going on. All right. Well, m is my common difference. I look above. The common difference is 25. So I'm going to go 25x mx plus b. B is my y-intercept. That's 15. There it is right there. From recursive equation to explicit formula. What do you guys think? Isn't that cool? Man, I don't have too many people out there saying that was a cool problem, Mr. Givens. I'll wait patiently and see if we think it's cool so we can move on. Or if you have a question, let me know.
That was a cool problem.
That was a
It
cool.
was a cool problem.
Thank you so much. You guys just make my day.
I'm a liar.
All right. All right. All right. Now, last problem right here. Explain what. There's a typo right there on our test. Explain what that should be it means. I didn't write that problem. I want you to know that. That wasn't me. I don't think so anyway. Number 18, explain what it means for a sequence to be arithmetic and what it means for a sequence to be geometric. Use examples or different representations to provide a complete description that describes the growth of each type of sequence. All right. And I said a little note for you guys. You might refer to number 1. Because on number 1, didn't we have some sequences that were either arithmetic or geometric? Oh, yes, we did right there. So you could talk about those and just write that. I'm going to go even simpler than that. Now, here's what a lot of people did. They started here and they said arithmetic implies we have a common difference. D equals a number. And some of you wrote that out. That's fine. I'm going to make this really simple. I'm going to say, an arithmetic implies I have a common difference, and I'm even going to give the common difference here too. So now I'm just going to do a sequence that has a common difference of 2. So how about I start with a 1, and then go plus 2 is 3, and then maybe a 5, and then a 7, and then just go dot, dot, dot. Okay? Is that an arithmetic sequence? Sure it is. Common difference of 2. And if you can do that, you understand this. Keep it simple, you guys. Now, geometric does not have a common difference. It has a common ratio. So let's do something like a common ratio of 2 right there. And how about we start with the 1 again? Now, instead of adding 2, I am multiplying by 2. So 1 times 2 is 2. 2 times 2 is 4. 4 times 2 is 8. 8 times 2 is 16. And I can keep going as far as I want. All right? But that's it. That's number 18. You've got to know arithmetic implies we are adding or subtracting. Geometric implies we're multiplying. And if you use the language of common difference or common ratio, you're acting like a mathematician right there. And then some of you did that, but did not give me an example. And I had to take 1 point off of each of these. I want to know what an arithmetic implies, and I ask you for an example of one. And you can do whatever you want as long as it is arithmetic up here and geometric down there. And that, my friends, was your first test of the year. Questions anywhere?
So I have a question. It's so
Okay.
so for number 18, so we have to show the example and do like a verbal explanation of what it is.
Exactly. And you could
Okay.
write out that. If you say arithmetic means you're adding or subtracting, that's fine.
Mhm.
Or you could just say that's a common difference and then give me a common difference and use it for your actual sequence.
Okay,
Okay.
cool. Thank you.
Betcha. You betcha. Any other questions? I can go back to anything you want one more time. Okay. Now, nope. Somebody's there. I guess not. Okay. Now, I will clean this up as you guys are testing. All right. So now, let me come back to you guys. And let's stop presenting this. And you know what? How about you guys make my day and unmute the video if you're comfortable with that for a second so I can see some faces and see how you guys are doing. I got Caleb. I still just got Caleb. Oh, you're breaking my heart, you guys. Oh, here comes on Amelie. Thank you, Amelie. Your camera's on, but I can't see you yet there. And there's Sophia. Right on. Okay. All right, you guys. Now, let me go back to, I'm going to go to the third period Google Classroom, but the same thing is in your Google Classroom. So watch this carefully so we all make sure we know what we need to do now. So present now. I'm going to the third period Google Classroom. So that's going to be a Chrome tab right there. Third period right here. Share. All right. Now, let me go back to stream and get back to as if you're opening it up for the first time. Now, a little reminder, you guys, okay? You probably already printed this out to take some notes on. At least I hope you did. That'd be awesome. Now, you did notice hopefully right here, this is my video of the first review, all right? And again, if you need to think about something one more time, you know, every problem that we talked about here, there's a similar problem on the review right there. You can open up that review and pause it, start it, stop it, whatever you want. It's good stuff. All right. I know it is because I created it. All right. Now, so you have that, but now you are ready to do a retake. And it is almost 11 o'clock. I would like this retake done by 2 p.m. All right. So all you do is go down to summative assessment. And you see above the Module 1 exam is the Module 1 retake. Boom, right there. And I even put a note here. Only students who attend today's test presentation, which was 11:10 at 10 a.m., are allowed to complete this retake, which must be turned in on 11:10, that's today, by 2 p.m. Thank you. So you click on your link and your test will open it up. And at 2 o'clock today, I am going to start correcting. Okay, I am coming back to you guys now. All right, does everybody know what they need to do?
Yeah, Mr.
And-
Gibbons.
Yes.
Yeah, Sophia, yeah.
Oh, Amelie can go first. Oh, wait. I don't
Go
know.
ahead, Amelie, what's up?
Were you asking a question, Amelie?
No.
Oh, okay. Well, do we have to stay on the call or anything, or can we just do it?
Not at all. You are done. You can. We're not going like a regular class. It's not like asynchronous now and you're doing it. All I'm going to do is at 2 o'clock today, I'm going to open up those tests and start grading. I will not look at anything until 2 o'clock.
Okay,
So you
cool.
got plenty of time. All right. You even have time to watch my video if you want. You have time to check more notes. Whatever you need to do, just make sure at 2 o'clock you are done.
Okay,
And
awesome.
I promise I will replace your original score with this score if you can improve, which I know you will. All right. And with that, if you guys don't need anything else, I can let you go. Okay. Everybody good? Does anybody out here need anything?
Nope. I think so.
Okay. Now, I don't know how to stop my recording. I think I just have to end this. So you guys may check out, go take that test, and good luck. All right. And you guys
Have a
thank
good
you for
day.
coming in. What's that, Jay?
Have a good day.
Hey, you two have a great day. I
Thank
get to
you.
teach, I get to teach my college class now, so I have one more
Oh,
class.
lucky
to teach
you.
them. Yeah, it is lucky, man. I feel blessed to be
Oh.
able to teach that class.
Oh my
But
gosh.
you guys are my favorite. Remember that.
Oh wow.
All right. All right.
You gotta stay humbled. All right. Bye.
No, it's so cool because I have a schedule where I get to teach you guys who are our younger students at Black Hills High School, but then I get to teach the college classes too. So I get the young and the upperclassmen. It's a good mix.
I get it. Yes.
Yeah, I like it. They've done that to me my whole career. All right, guys. Get out and out of here so I can stop this recording because I'm starting to babble and, you know, there's going to be a recording of this.
Okay, bye.
Bye, Mr. Gibbons.
Bye-bye, Sophia. Good luck. Jong?
Thank you.
Yeah, thank you. Jong, did you get everything you need there?
Yeah, but could you share your screen again? Go to slide 7, please.
Slide 7. You got it, bud. Caleb, do you have everything you need?
I went to Classroom and is the retake on a Google slide?
The retake is go down to the classwork and the summative assessment, and it should be in Google Slides.
Okay, cool.
Okay, got it? Okay. So, Jong, I'm going to open up that slide 7 then, bud, if I can find it again. Oh, yeah. Here it is. Okay, so let me present my entire screen. Share, and Module 1 exam, slide 7. There it is right there. Okay, can you see it, John?
Yeah, I see it.
All right. Let me know if you have any questions or anything you need, man.
So is the 2 the what is it? Like addition to the
This symbol right here, that little star means we're multiplying by 2. Okay, so we're multiplying by 2, and that's because my first f of x is a 1, and then 1 times 2 gave me a 2, and then 2 times 2 gave me a 4.
it could be addition, right?
It could be, but it's not in this case at all, because again, you've got to be able to add the same number every time. And there's not a number I can add to 1 to get a 2 and then add the same number to 2 and get a 4. That's how I knew it had to be multiplication.
Okay, thank you. That's
You
all.
betcha. And that's it. All right, John. Good luck,
Yeah.
man. All right.
Have a great day.
Hey, you too. And I really appreciate you getting here, and I enjoyed our conference yesterday too. All right.
Okay, bye.
All right. Bye-bye.